Hello everyone, let us prove the following. PQR is a triangle, right angled at P, and M is a point on QR such that PM is perpendicular to QR. Show that PM square is equal to QM into MR. So, what is given here? Triangle PQR is a right angled triangle. It is right angled at P. That means angle P will be 90 degrees. Okay. So, obviously, what happens? Opposite to this right angle will be the hypotenuse of that particular triangle. So, QR becomes the hypotenuse of that particular right angled triangle PQR. And M is a point on QR, right? And PM is the perpendicular drawn from P to QR, and M is a point on QR. This is what given in the data, right? We need to prove PM square is equal to QM into MR, right? Okay. Right. Now, in the triangle PQR, it is a right angle triangle and it is right angled at P, and QR is the hypotenuse of the triangle and PM is the perpendicular drawn to QR. Okay, what do we know? In a right angled triangle, the perpendicular drawn from the right angle to the hypotenuse divides the triangle into two similar triangles. Okay, అంటే ఇక్కడ పిఎం పర్పెండిక్యులర్ లైన్ డ్రాన్ టు ద హైపోటెనస్ కదా. అందుకని మనకి ఏం తెలుసు, ఒక రైట్ యాంగిల్ ట్రయాంగిల్లో హైపోటెన్యూస్కి మనం ఆ రైట్ యాంగిల్ నుంచి డ్రా చేసిన పర్పెండిక్యులర్ లైన్ ఏదైతే ఉంటుందో ఆ ఓల్ ట్రయాంగిల్ని రెండు సిమిలర్ ట్రయాంగిల్స్ కింద డివైడ్ చేస్తుంది. Okay, what is that? The perpendicular drawn from the right angle to the hypotenuse divides that right angle into two similar triangles. So, here two triangles are formed after drawing that particular perpendicular. What are those two triangles? Triangle PMQ, alage triangle PMR. So, as QR is the hypotenuse and PM is the perpendicular drawn, we can say that triangle PMQ is similar to triangle PMR. Okay, right? So we have proved that triangle PMQ alage triangle PMR ఈ రెండు కూడా similar triangles. ఎందుకని పిఎం అనేది రైట్ యాంగిల్ ట్రయాంగిల్లో డ్రా చేయబడినటువంటి ఒక పర్పెండిక్యులర్ హైపోటన్యూస్ మీదకి డ్రా చేయబడినటువంటి ఒక పర్పెండిక్యులర్. ఓకే, సో హియర్ వీ హ్యావ్ ప్రూవ్డ్ దట్ ట్రయాంగిల్ పిఎంక్యూ ఈజ్ సిమిలర్ టు ట్రయాంగిల్ పిఎంఆర్. ఇప్పుడు టూ ట్రయాంగిల్స్ సిమిలర్ అయినప్పుడు మనకేం తెలుసు? వెన్ టూ ట్రయాంగిల్స్ ఆర్ సిమిలర్, we know the ratio of areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. It is also a proved theorem. So what is proved? That the ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. Okay, so it is a scenario that we use in similar triangles. As we proved that triangle PMQ alage triangle PMR, these two are similar triangles, so we can apply this one to those two similar triangles. We can apply this property to those two similar triangles and mata. Okay, so for your convenience, as we are finding out areas of those two triangles, to make you understand base and height clearly, I have rotated this figure. Okay, so this figure I have rotated. Okay, same measurements, everything, just we need to rotate just to understand base and altitude clearly, height clearly. Okay, so here we have proved that triangle PMQ is similar to triangle PMR, right? So according to similar triangles criteria, what can we write here? The ratio of those two triangles will be equal to the ratio of the squares of their corresponding sides. So applying that property, we can write that area of triangle PMQ by area of triangle PMR is equal to PM square by RM square. PM square by RM square. Okay, we can write corresponding sides rm square, pm square by rm square. Right, now coming back to the area of a triangle is a simple formula that we know. What do we know here? Area of the triangle is nothing but half into base into height. Okay, so applying the same formula of area of triangle. So triangle a pmq we are taking half into base into height. Here for pmq, base will be qm, base will be qm, and height will be pm, right? And we have written like this, half into qm into pm. In the same way, area of pmr we are taking. So area of pmr, base will be rm and height will be pm again. Okay, and corresponding sides pm square by rm square, they remain the same, no doubt. Okay, now we are simplifying further. Here pm and pm gets cancelled. Okay, and we have taken this square to this side. Rm square can be written as rm into rm. This is done only for simplification. Okay, to cut the similar terms and to get the things easier, we are making all these things. That's it. Okay, so rm square is written as rm into rm. Right, so here after substituting all these values, so we have taken this rm into rm this side, and rm, one rm will get cancelled, will get cancelled here. And finally, what are the terms remain here? Half and half gets cancelled. Okay, one rm gets cancelled, and pm is gets cancelled. After doing all the simplification, finally what terms are remain here? qm into rm is equal to pm square. qm into rm is equal to pm square. Right, so we have to prove that only. So pm square is equal to qm into rm, so it is proved. Okay, here we have used the two similar triangles criteria, as well as perpendicular drawn to hypotenuse makes a right angle triangle into two similar triangles. Okay, these two properties are used to solve the problem. Okay, are you able to understand? Hope you have understood. Thank you.